Hello and welcome. My name is Jim Fletcher and I'm here today to talk to you about instructional principles. So what are instructional principles? So you know that we're talking about cognitive theory and multimedia learning and cognitive load theory. So what it is Mayor has come up with several principles that help guide instructors in making presentations that will help students learn and kind of reduce the extraneous load that those students get from learning. Now, the one important thing is these are all done in the lab, and there are some exceptions to the rules. So even though it's been scientifically studied, it hasn't been scientifically studied to the point that they know whether it's going to work or not. And there are some what they call boundaries that these principles may not work for. The first instructional principle I want to talk about is signaling. And you may often hear it referred to as cueing, but what it is it just highlights the relevant information that students want or need to understand. By highlighting that relevant information, it kind of reduces the extraneous load that students have to decipher from a passage or whatever you're studying. You highlight the relative portions. It takes the extraneous load out because they don't have to go through and figure out what's going on, what they need to remember, what they need to write down, and things like that. Now, also for signaling principle, the one important thing is it can also be used to show relationships. So in the example that I have right here, it shows that, you know, the school books and everything is related to school. So you can do relationships also with signaling. And then for the example, it just shows that with the one side, the left side of the picture shows how, you know, you can use signaling to highlight for the mechanical design, and then the other side, the right side, doesn't have that, so students kind of have to figure out what you're actually talking about. Redundancy principle is the next principle I'd like to talk to you about. And what redundancy principle says is that you don't need to keep presenting the same information in many different forms: text, narrative, animation. It actually hinders the learning process and it creates cognitive overload. Students learn better when you either use the text and the animation or the narrative and the animation, but not from all three. That's just redundant, and it causes too much overload for them. As you can see from my example right here, they have both text, visual, which is animation, and narrative on them, and they've marked out which ones shouldn't be there. So like the first one, if you're going to use text and animation, you should not use narrative. And if you're going to use narrative in animation, you shouldn't use text. That's just too much. It causes way too much overload on the students, and there's just too much information for the audio and the visual channels to comprehend at the same time. So the last principle I want to talk to you about is temporal contiguity principle. Continuity is a hard word for me to say. So, and what it says is if you're going to use text and pictures simultaneously, then you need to do it so that there's no space between them. So like you see on this example here, you know, it's got the ABC and what they do on the top, and then they have the picture on the bottom, versus the one where everything is actually on the picture. You can see it and you understand what is going on. It just makes it better for the students to understand it and to view it that way. What the temporal contiguity principle does is, by presenting the text and the animation together simultaneously, you reduce the extraneous load on the students and the anxiety too. So from this example, this is a picture of the heart and the heartbeat and where each of the beats resides in the heart. Cardiac is one of the hardest things you're going to do as a paramedic or as a doctor or anything else, because there's just so much of it. And this actually helps take that extraneous load out. You can see where the AV node is, you can see where the SA node is, you can see the bundle of his, and you know where they are in the heart, instead of somebody just telling you the P wave goes from the AV node and you have no idea where that AV node is. So now that I've given you just 3 principles of instructional design, what I'd like to do is use them in a presentation. So what I'm going to be doing is doing a basic EKG reading class. And this is for the layperson who, goes to the doctor and sees that they have tracing of their heart, but they really don't know what it means. So what the EKG is an electrocardiogram, and what it does is it looks at the electrical activity of the heart. From that electrical activity, we can tell all kinds of things. So, this slide is a picture of a 12 lead that helps us look at different views of the heart, front, back, side, to see where the electrical activity is, how it's transversing through the heart, and if there's a problem. So the first beat of the heartbeat, the first wave, is a P wave. And what it signifies is the upper chambers of the heart, which are the atrials, firing. The next wave is actually a set of 3 waves, and what we call it is a QRS complex, and that is the ventricles firing, and that is the workhorse of your heart. The ventricles are where the blood is thrown. Specifically, the left ventricle is what pushes blood throughout the body. So in the QRS, you have the Q wave, which is the start of the wave. The R is the big upward deflection, and then the S is a downward reflection, and it may go down below the isoelectric line, which is this red line that I put across here. That is an imaginary line, but sometimes it won't. And then the very last wave of the heartbeat is the T wave. And what the T wave signifies is it signifies that your ventricles are ready to fire again. They're ready to go, they're primed, and they're going. Now, there is a wave for the atrials that shows that it is ready to prime, but it's buried in the Q wave and you never see it. So I hope that this has helped you look at what you know what the heartbeat is, know what parts of the heart it is. Now, if you want to know where the electrical activity comes from, this slide that I'm showing, and you saw it in the earlier presentation, shows you where all of the waves originate in the heart, and that's complicated, and it's going to cause you some extraneous overload and cognitive load, and we just won't go through it right now. So I hope you enjoyed my presentation. Thank you, and stay tuned in a couple of weeks and I'll have my final video. Thank you.